Right. All right. So today we're going to learn about scatter plots and regression. Okay. On one of these sheets, you have directions to how to calculate a scatter plot and input data into your calculator. All right. That's a great resource for you. It looks like this. Okay. For sure. All right. It looks like, let's pull it up here. It looks like this. Okay, save this. All right, start, fold the page back or something. Okay, just to make sure you remember how to all this stuff. All right, so our learning targets for today, we're going to use a calculator for statistical analysis, understand inputs and outputs of data, and apply real world knowledge and ideas to a data set. All right, so we're going to look at this fast food example. Okay, we're going to input this table, this data set into our calculators or using our calculators to calculate, okay, our regression line and see how the variables are related, all right, using the scatter plot. For this, all right, so the first thing it says, create a scatter plot for your data on your calculator. So I'll bring up my calculator here, okay, to input the data into my calculator. All right, I'm going to go to Stat, Edit, which is the first one. Now you may have data in here already, okay? And you've probably done this when back when you were a freshman, you did this a little bit. All right, so we'll go up to L1, press clear, and press enter. All right, so now everything is gone. Okay, so then I'm going to take my the fat data, the data about fat. So we'll call this my X and I'll call this my Y. All right, so in L1, which will be my X, I'll just input all my numbers, 19, 31, 34, 35, 39, 39, 43. Now the order in which I physically input this is not terribly important as long as it corresponds. So with the 19, you must have 410 right next to that. Okay, with 31, I must have 580. Okay, it's easier just to do it in order, all right, so then you won't make a mistake along the way. Okay, but if by chance you do not or you mistype or something like that, don't freak out. It's not the end of the world. It'll be all right. Boom. There you go. So to create a to get out of this, first of all, I want to press second mode, which is quit. All right. So to create a scatter plot for my data, okay, on this y equals here, there is a stat plot button right above it. So I'm going to press second stat y equals. Okay, right now my plot one is off, so I'll press enter. I want to turn that plot one on. For a scatter plot, that is these dots. Okay, the dots represent our scatter plot, so I'll press enter if it's not already on there. Okay, or it's not already selected, excuse me. For your X list, you want to be L1. All right, that's where we put all of our fat grams. And our L2 will be our Y list. All right, to change that, let's say L1 is not in there. I'm going to press second 1, and that will give me L1. To get L2, I'll press second 2 to get L2. Okay. Now I want to graph this, but if I just press graph, the data won't necessarily come up. Okay. So to have the data come up, I'm going to press zoom. And, whoops, wrong button. Zoom stat, which means statistics, which is what we're doing here. Okay. This little introduction to statistics, whether or not you take statistics here at the high school or in the future. Hello, that'd be, come on. Okay. All right, and we're back. Okay, sorry, my little smart view just, I don't know what happened. It froze on me there. So anyway, we're going to scroll down from zoom and go to stat, which is number 9. So I'll press enter, and now boom, my scatter plot shows up. Okay. So what I want you to do next, all right, so now that we created a scatter plot with our data, all right, what I want you to do next is in your own words, describe how the variables are related. All right, describe how the variables are related. Okay, so go ahead and pause the video and do that. So you could have said any of the following. I mean, it doesn't have to be the exact. I said something along the lines of as fat increases the amount of calories, tends to increase as well. It's possibly linear. Okay, there could be a direct relationship between the fat and the number of calories in food. Okay, so now we want to use our calculator to create a linear regression for the data and what is your equation. Okay, so to do that, I'm going to go to stat, calculate. All right, and I'm going to go down to number 4. Okay, number 4, I'm going to use number 4. You can use, I believe, number 8 as well. All right, but just to stay consistent, to make your life easier, going with number 4 would be the best. Now, depending on how new or old your calculator is, you may have a different window than what you see here, and that's fine. Okay, they still do the same exact thing. All right, so for mine, okay, so I need to let my calculator know that I'm referring to the list that I input into my calculator. So the first one I'm going to do, I want L1 to be, which is my fat content, to be my X value. So I'll hit second 1 for L1, comma, second 2 for L2, comma, and I want my calculator to actually physically graph this line or graph this function for me, equation for me. So I'll press vars. I'll go over to y vars, enter, and then y1, and now press enter. So it spits out this nice equation for us here, okay, where y equals ax plus b. Well, we've seen something like this, y equals ax plus b. You're used to seeing y equals mx plus b. Okay, so in our case, a is the slope, and b is still the y-intercept. Okay. For our equation was a was 11.555 or 0.555. So I'd write. Let's see. Let's get this stuff. Oh boy. Oh boy. Oh boy. Oh boy. Hey. Oh boy. Oh boy. There we go. Okay. So y equals 11.0555x plus, what was it, 210.9538.7. And the more decimal places I write, the more exact our answers will be towards the end of our notes. Okay, or the more exact your answers will be in an actual quiz or an actual assessment in the course. Okay. Graph your equation on the same viewing window as your scatter plot. Does this accurately, or is this an accurate model of your data? Okay, well, luckily we put in y1, right? So I'll just go over to my graph window and look. Is this an actual good representation of our data? And I would say yes. I would say yes. Why don't you think about it? Yeah, I would say yes because the line seems to fit the data. So I'm going to say yes. Line seems to fit data. Okay. Think I wrote big enough there? For sure. All right. So now what I want you to do is to interpret the slope. Interpret the slope of the linear model within the context of the data. So within the context of our problem, what does the slope represent? Okay. Well, our slope was 11.055. Okay. So our relation is, comparing fat, grams of fat to calories. Okay, so something you could say. So why don't you pause the video and write something down, and see what you can come up with. All right, so I wrote something down like for every 1 gram increase in fat, the calories are predicted. Okay, notice how that's in red, very important part, predicted to increase 11.055. Okay, it is a prediction. It's an estimation. It's not exact because this is an equation. If you look at our line here, it doesn't hit all of our data points. Okay, so it is a prediction. It's predicted to increase 11.00 or 055. All right, so knowing that, okay, let's try to interpret the y-intercept within the context of our problem or of our data set. All right, pause the video. So I'm going to type this out here, okay? So a burger with 0 grams of fat is predicted, again, big word there, predicted to have 210.9537 calories. Okay, again, it is predicted. This is an estimation. It's not necessarily, oops, this is a prediction. It's not for sure. All right, it's not always going to be that way. Okay, we don't know for sure. All right, so let's use your equation to predict how many calories there would be with 28 grams of fat. Does this make sense? Explain. So interpolation, now you've talked about this word before in your previous math classes, okay? Interpolation is a number that lies within our data set. So our data set for grams of fat was right here, okay? 19, 31, all the way up to 43. So 28 is within that actual data set. There's a number between 19 and 43. Okay, well, remember our fat grams, or grams of fat, represented our x. All right, x represented our grams of fat. So if I were to plug this into my equation, so it'd be y equals 11.055, and then x went here, so I'll put 28 instead, plus 210.9537. So now remember what I said, writing as many decimal points as possible is a good thing. Okay, this is when that helps, okay, when it helps predict. So our answer, if you solve this out, I got 520.508. Does this value make sense? All right, does this sort of fit within our data set? Yeah, it kind of does. If 28 is right here, 520 would be in between 410 and 580. So I would say yes. Seems reasonable. And I would ask you to actually explain. I verbally did it, but I'd like you to write something down. I just don't have much space here. Okay, so why don't you try the next one? All right, pause the video, okay, and try. Okay, so this one said use your equation to predict the extrapolation. All right, so this is an extrapolation because 50 is outside of our data set. It's a number larger than 43, okay? And what I ended up, what my answer was after I inputted 50 in for my x value, I got 763.729. Now, this does make sense within the context of our problem, but we must be careful, okay? We must be careful when solving for extrapolations, all right? So we don't know for sure that it's always going to make sense, right? But that is it. Okay, feel free to rewatch this. I know, we went through kind of quickly on how to do this portion. Put it in your calculator. Watch as many times you need. That's the beauty of these videos. You can rewind. But that pretty much sums it up for our scatter plot and regression notes.